Hey everyone, how are you going today? We are looking at the Orange Pi RV2, which they're kind enough to send me, given we do a fair bit of RISC-V stuff. Now this is fairly new from them, and they've also sent me an eMMC module for it, which is very handy. We of course have the new desk finally done. I finally got a new camera, so this should be better quality, but I haven't got autofocus turned on. The lighting is still a work in progress, and I have fiber internet now, so it won't take me 5 hours to upload a video. Moving on to this though, this is very interesting because Orange Pi, who are a bit controversial at times, don't usually make RISC-V hardware. Most of their stuff is ARM, rock chip. They have done some other things in the past, but you know, people don't often stray out of their comfort zone. They're definitely very comfortable with ARM. That being said, SpacemiT has been making big waves recently in the last year or two with their RISC-V hardware, including the Muse Pi Pro, which we'll be having a look at in not too long, but not this video. So one of the things that they make is their cores. Their intellectual property is their, oh, it's sealed, their IP cores, and they license that to others. So this is one of those examples where the SoC on this is made by KY. If we have a look closer, that's different to the adult KY that you might be familiar with. It's a KY X1, and that has 8 of the X60 cores from SpacemiT. So they're licensing that to make what is hopefully quite a neat RISC-V platform. So what we need to do is get into all of these bags, have a look at its specs and its hardware, and actually give it a shot, because there is 2 different operating systems that we can try on there as well. There is their Harmony OS, and there is their Ubuntu build for it, so both supporting RISC-V. Now, as we can see, if we have a bit of a closer look here, we have our, I haven't set my camera up in a great spot. We have our SoC, we have RAM, we have Wi-Fi, that's Wi-Fi 5 and Bluetooth 5, I believe. We have an eMMC slot over here. We've got our USB, let's do it this way around. So we've got our USB power in, USB 3, dual gigabit LAN, HDMI out, USB 2.0 and 3.0 there. We've then got our MIPI CSI connectors. Now, I'm a bit confused about this because, oh, that's an RTC battery port and your normal pins. Here we go. So there's 2 MIPI CSI quad lane connectors there, which is excellent. That's going to be your MIPI DSI connector for an LCD, eMMC, SD card, and your second M2. So these M2 slots are both M-keyed, and they're PCIe 2.0 2-lane. So you're not going to get a GPU doing much on there, but they are very handy for say 4G modules, although it doesn't have a SIM card slot. You could run NVMe, that looks like 2230. So it's great that it's got M2 slots, but of course it's not the fastest. Same as only having Wi-Fi 5 instead of Wi-Fi 6. I find that a little bit strange too. But I mean, these aren't meant to be high-speed gaming systems. These are embedded low-power systems, or single-board computers, SBCs, if you haven't heard that before. DDR4X, which is pretty good. This model that they've sent me, I don't even know if it says, has some RAM, I assume. It does have some RAM, that's it there. We've got our SPI flash and then our normal other supporting components on there. Now, the X60 cores in use in here are RVV 1.0 and RVA 22. They're missing about 10 instructions from what I understand to be RVA 23, and that's a 22 nanometer fabrication process. Now, the output on here is 1080, 60 FPS max. It doesn't do 4K as far as the documentation says. Not really sure why, but so be it. You got your 26-pin header here, which looks like it's pretty much the normal 26-pin header format. Doesn't look like we have an onboard antenna. We do have a power button there, which could be handy. And lastly, it says it needs 5 amps, which I find a little bit strange, or it recommends a 5 amp power supply. It also does have the option for 1 amp out. I'm not sure where, but it says it supports 1 amp out. That is probably just on those headers. And you've got your debug ports in there as well, along with what looks like extra USB connectors. I might have to check the manual. Those could be the 5-volt out pins that they're talking about there. So in pretty much standard credit card form factor, having SD card, dual M2, eMMC is pretty good. RISC-V, awesome as always, continuing to support the ecosystem. USB-C is great to see. That does work in dual mode from what I understand. and plenty of USB ports, along with the dual LAN. So there is an OpenWRT build for this, and because it's got Wi-Fi, this means you could build yourself a tiny RISC-V embedded router, and I expect it would work quite well. So what we're going to do now is we're going to plug this in, and I'm going to get my power meter as well so we can see what it's actually consuming and see what happens on first boot with the eMMC that they sent me. After that, we'll likely flash it because we've got Harmony OS and Ubuntu to try out, and we'll do the usual. We'll make sure it joins the Wi-Fi, we'll try the graphical performance, try out the embedded browser, basic benchmarks, and decide how impressed with this thing we are. So if you want to give me a moment, I'll be back. All right, so the first thing that I really want to check is if it supports PD. So I've got my silicon USB cable here. I've got these available in the store if you want to buy one. They're from Pine64 and they're only a couple of bucks. This supports 65 watts. I've got it going to my Pine Power, which I also have in stock, and it's in the PD port. So we'll see if it does power on. All right, so this does support PD, which is really handy. It's in 5.2 volt mode. But I'm going to unplug that for now because we don't want it to do very much. I'm going to put in my FNB 58. There we go. Little kajigger. And then I'm just going to use this tiny cable so we can see what it's actually drawing. There we go. So it's not drawing all the amperage that it said it needs, but I'm fairly confident that this eMMC is just going to be blank and not have anything on it. So we'll have to use ADB to flash that. I've got the two different images. I think we'll go for the Harmony OS first, which is their Orange Pi OS. And I'll make it very quick. I'm just going to show you how to flash it. We're not going to go through the entire process of getting it set up. They do have instructions for Windows and Linux. You can use their tool, which actually comes with some of the images, or you can use ADB, which is usually my preference. It depends on what SoC you've got and what board it is and everything like that too. So always read the documentation. I'll get that set up though, and we'll come back to this in a tick. Hold tight. All right, so after a fair bit of messing around, unfortunately to use the eMMC, you kind of do have to do it on Windows. I can see it's using fastboot, and I tried to do the commands myself. I got all the strings out of the .NET managed executable that they've got. I even translated the output from their Windows tool to correlate it, but I couldn't get it past detecting the DFU device. I think I need to kick it from DFU mode into fastboot mode, but I'm not entirely sure how to do that. So I will put a link below to the fastboot process that you should need to flash it on Linux if you can get it into the right mode. In the meantime though, I did unfortunately just have to flash this on Windows. What you can do is you can flash the SD card, boot the on Linux, then boot to the SD card, then use that to flash the eMMC, but I'm not going to screw around with all of that. So what we've got now is Open Harmony on the eMMC on this Orange Pi RV2. What I did want to do though, which I feel is equally important, is educate you with the option if you ever get into making these things yourself. Now, what I mean by that is PCBWay, who are of course sponsoring this video again. Now, the reason I use PCBWay is because their quality is excellent, and sorry about my chair creaking, but I try all the others occasionally and I just keep coming back because of everything they do that is just phenomenally good. Even if you go to their CNC machining, the amount of materials that you can pick from here is just insane. No one else does that. Now, they also had the 11th badge design contest, and I have just entered this, or I have entered this and submitted everything. So you'll see on my YouTube channel next to this video, there's a little demonstration where it's just playing the animation, but normally that's touch animated. And I've got a link in here to GitHub where I have all of the code, the PCB files, everything like that, completely open source with examples and explanations and all of that. That was made possible by PCBWay. So I'd like to thank them for that and supporting this video. If you want to support this video and the sort of things that I do also have a Patreon, which is as cheap as about $3 US or $4 Australian per month, and you get support and you get your name called out and some cool stuff like that. So thank you to the patrons that I have. But now back to this thing. We're going to plug it in, we're going to have a look at what it's doing. So that is all ready to go. I've got the USB keyboard and mouse there, and then I'll just slap in some power. Actually, HDMI, that's what we want to look at. Now I'll give you a live feed. The little green LED is blinking and it's drawing about 500 to 600 milliamps, so 2 watts and loose change. It's not drawing anywhere near the 5 amps it was talking about before. I'm continuing to monitor it though. It is definitely doing something. The green light is flashing in a heartbeat-like pattern, but the amps drawn are all over the place, up to 850 milliamps just then. Oh, there we go. Got a little Open Harmony logo. And then we get the year 2000 at 8 AM. All right, so this is interesting. We have SIM status and we have 11% battery. And it's an Android interface. Cool. That's not gonna work for me because it's not in English. It does have 2048 though, which is neat. There's no right click and I don't know how to do anything. So this Open Harmony doesn't really look useful. I mean, if I understood more of what I was doing, I could possibly figure something out. That's going to be system monitor, calculator. That's maybe settings. Or that one, that looks like the internet. But this is obviously, oh yeah. Can I search in here for English? No. So this is obviously not optimized for a user experience. Okay, I'm going to go back. I'm going to flash this with the Ubuntu image instead because whilst that is great, this I want to be able to actually use. I don't want Android and I don't want Chinese. I want English because that's the language that I speak. I'm sorry if that is not suitable for you. So, going to go flash this again. I'll be back in a tick. So now I've of course gone to flash the eMMC, but it's only an SD image. They don't have an image available for the Ubuntu build to put directly onto the eMMC. So we're going to have to try this process from start, which means what I want to do is restore this. So it's Orange Pi, that one, onto this 16 gig SD card that I grabbed. Now, if you need an SD card, I do usually have them in stock. Once that SD card has been imaged, which will take not very long by the looks of it, a couple of minutes, we can see here we've got to boot up to the SD card and then run that NAND SATA install, which is a odd little script that looks like it will just write everything across and take approximately 4 minutes, and we can boot to the eMMC. Now, the reason I'm doing that is because the eMMC is typically going to be faster than the SD card. And it's good to test these processes anyway. That will give us an idea of what you're going to experience. So I'm using disks in Ubuntu or Linux Mint Mate here to flash this SD card. I've just got a basic 16 gig SD card. If you're on Windows, you can use Balena Etcher, and you'll see in their instructions they do actually cover how to do this. So burning TF card, yeah, that one pretty much. So just download Balena, install it, use that to flash it. It's pretty straightforward. So I'll let this finish restoring the disk image and then we'll come back and boot it up and probably move it over to the eMMC depending on how we're going from time. And of course at the end we're going to benchmark this too, so you'll have some Geekbench RISC-V scores there. Hold tight and I'll get back to you very soon. That's all done now. So I'm going to put this SD card in here. We've still got our eMMC attached, and we'll plug the HDMI back in because we're going to need that. And we'll of course monitor the power consumption. Just flip that back around. There we go. So if we jump over to the HDMI input, we've already got display, which is good. That gives us a little bit of information on it having flashed successfully and booting from the SD card, because we know the eMMC had nothing at the start and then had a very different image with Open Harmony. So it looks like by default it is going to boot to the SD card over the eMMC, which is really handy if you accidentally corrupt your operating system. You don't have to try to recompile U-boot or put any jumpers on or anything like that. You can just image a fresh SD card and use that as your recovery environment. So now we can see it's resizing the file system on first boot, which is quite normal and expected. We'll just wait for this to finish booting. It's only drawing again like 650 to 800 milliamps. So I'd say you can probably run this off a 5 watt, so 1 amp power supply. I wouldn't necessarily recommend it. I'd say 2 or 3 amps. Given this is 8 core, once all cores are in use, 3 amps is probably going to be reliable, but they do say 5 amps. So if you're using 3 amps and it starts to crash out, just be aware that there is probably a very good reason for that, and that reason is that my information is wrong. This is just all my assumptions. All right, That's what we're a bit more used to. So what we're going to do, now we've found a terminal, let's just jump into root mode. And I know you can do sudo -i, but whatever. Orange Pi is probably going to be the password. Excellent. So now we want to do the NAND SATA install, apparently. Yep, so boot from eMMC, system on eMMC. Okay, so you've got quite a few options here, more than it showed in the documentation. That's what we want to see. ext4 is perfectly fine. So it looks like this is working as advertised. It's formatted the eMMC. I really hope it formatted something. It's doing some sort of check, and then I'm not exactly sure how it grabs this image. It might just be cloning the SD card, which is very interesting. Don't know how crash consistent that is. And this says it's going to take 15 minutes, not 4 minutes. So I'm not going to go ahead with this, but this gives you an idea of the process. We don't need to worry about the eMMC for our purposes here. Now, if we go back to a desktop environment, that's no, F1, F2. All right, so this is back on F2, and we can see that is working. We'll have to see, it is a little bit laggy. It looks like the Wi-Fi is working out of the box. So let's join, this lag is a little bit painful. I'm guessing you can feel that too. So if we join Pi-Fi, the default password on this image is Orange Pi. I don't want to join IoT, that was the wrong, that's probably what it was asking for, wasn't it? That was definitely the wrong password. I want to join Pi-Fi. Don't know what's going on there. Should be about joint connected. Excellent. So now let's have a look at display settings. What's in here? And let's grab a terminal whilst we're at it. So yep, 1080 is what we wanted, 60 Hertz. Let's do it the proper way. Orange Pi. So we've got 4 gig of RAM. We're using less than a gig. That's pretty nice. And if we have a look at the CPU cores, we've got our 8 cores there of KY-X1s. You can see there the X60 cores there from SpacemiT. So that's looking pretty good. And if we go to df-h, we can see that has expanded to 15 gig to fill up that partition. So that's all good and happy. What web browser do we have built in? We have Chromium, as expected. Now, I'm going to put my money on the graphics drivers being a little lackluster, and I didn't see anything in the instructions about that. So let's do basemark WebGL. This will give us a good idea of just how much power it's consuming too. We should see this go through the roof. So basemark WebGL. And this is a 6.6 kernel, which is quite impressive. Let's start this and see how far through it gets. Can't find any information in the user guide about 3D. Now, this is not working. So if we go Chrome GPU, we're going to see a lot of things being unhappy in here, but we can try to manually override it. So there is no web GPU, there's no Vulkan, God bloody hell. So if we go Chrome flags, let's just turn on a few GPU things and see if it gives us a little bit more performance. Because as it is, we're probably going to struggle even just to watch YouTube videos. You can see I'm typing and not much is happening. So override software rendering list. Yeah, we'll do that, and probably use unsafe web GPUs. We'll use that as well. And was there anything? Oh, that might be enough to give us what we need. See what it does. Close these things. Close terminal. All right, Chrome GPU says everything but Vulkan. That's pretty good. This will quite likely crash though. Just going to see if we can forcefully enable Vulkan 2. If it does crash, I might try turning that back off, but I believe these latest Ubuntu builds are meant to forcefully use Wayland. But we did get a little X cursor before, so I'm not actually all too sure about that one. We've got everything there that we need. So let's go back to this basemark test and see what it wants to do about it. God, I miss Google looking like that. I wish you could make it look like that permanently easily. I got to stop doing morning videos. Apparently it's not my thing as far as talking goes. There we go. It's actually doing some stuff now. And it's still only drawing 800 milliamps. See how it goes with this bit. This is the bit that I expect to crash. It's going to be doing 3D. Yeah, something went wrong. All right, that's expected. Let's turn Vulkan back off again and retry that one, because that very well could be Vulkan. Vulkan, of course, requires very specific APIs exposed, which this may not have. So if we go back and we rerun this test, see if it still crashes. Yep. All right, so what we might want to do then is we can try toggling these two. It's going to try to use GPU acceleration as best it can, but I've got a feeling the issue here is going to be the drivers, specifically Panfrost, Panfork, and all of that Mesa awesomeness, which they've configured to obviously be stable. But, whew, all right, so we'll disable that, and we'll go GPU. And we want to unsafe web GPU, just try that. So we've swapped those two last options. I don't think this is going to fly, but what we can still do is run Geekbench on it. And that's going to be important too, because it's going to give us an idea of this actual SoC on here, which isn't warm at all, how powerful this is for the current RISC-V standards and the implementation that Orange Pi have on here. So this is probably going to crash again with this combination. It might not load at all if it's doing 100% in software and just having a very hard time. And it's just drawing 0.5 amp at the moment, so it's not particularly struggling. The fact it hasn't crashed yet is amazing though. Oh. Okay, it just, yeah, no, it wasn't a fan of that. So be it. So if we go have a look, that's all done. We can power off. I'm actually going to take the SD card out now and just hard power cycle it with the reboot button. And we should see this boot, first boot from the eMMC, and get an idea of how fast it is too. Not bad. If it has to expand again, I'd be annoyed because it could have done that in the process, but it looks like it's past that and it's going through everything, yep, straight into graphical mode in a second, graphical target. Otherwise, of course, you wouldn't have all these extra things that we just don't need started. There's GDM, and it's got Docker on here as well. I don't know why they'd have Docker and Containerd all pre-configured and starting on a device when they're already going to be a bit limited on performance anyway. It just hit 1 amp or 0.99, which is good to know. So the last two things we're going to do then is have a look at what we think of it so far, what its use case is going to be, and we'll see where it goes on the SBC tier list. So this is something that I've been putting together as I test out or try out or review or unbox more and more SBCs. So the SBC tier list is just a bit of a ranking that I've got for them, and I'm glad to see the Wi-Fi settings stuck across reboot from SD to eMMC, and the eMMC was fast enough. What is probably going to be interesting though, I didn't think about, is there's a 16 gig SD card and it's a 32 gig eMMC. So it has actually expanded. Okay, it must have done that as part of the flashing. Excellent. So you can see I've got a few on here and I'm continuing to add to it. This one I think it was, is that, no, that's the, what have I got in here? No. All right, well, something worth having a look at if you're really curious about this sort of thing. On this channel, I'm not sure if you're new here or not. A lot of you are, and it's really good if you like and subscribe, by the way. If you like this content, hit subscribe so you can see when I release more videos. It's about once every 2 weeks at the moment, but it's not all SBC related. Some of it's just general compute technology and things like that. So anyway, whilst that struggles to load the YouTube page, let's have a look at this. So assessing the criteria or the rankings for this, we've got a few things to look at. First of all, price and availability. So I don't stock it. I've considered it, but there's minimal margin. They've got it basically through AliExpress, which I don't think is really good enough, but the price does look really good. If we jump back over to this one and we go Orange Pi RV2, God, it's great having fiber now. AliExpress or Amazon. So let's quickly check those out. And we've got 3 stores there. $63 for the 8 gig model. That link doesn't work. That link doesn't work. $80 there for the 8 gig model. That link doesn't work. So the availability isn't great, but the price is great. So I'm going to give that a 3 out of 5 for price and availability. I've got to write this down too, otherwise I forget. Next up, we want to have a look at the features and specs. So RISC-V, I like it. Dual M2, I like it. 26-pin header is excellent. I don't like that it doesn't come with adapters to actually connect your MIPI CSI cameras, that it's got Wi-Fi 5 instead of Wi-Fi 6 or 7. Definitely loses points for that. The CPU seems good. It's got dual Ethernet, which is excellent. The GPU is there, even though we can't use it yet. It's got 2 TOPS NPU built into this, RTC battery, 4-lane, dual 4-lane MIPI CSI is excellent, and MIPI DSI. There's no PoE support that I can see, and it doesn't support 4K. So there's a lot of good and bad there. Honestly, if they just swapped out the Wi-Fi for a better module, bumped it up to support 4K, but I can understand this SoC might be struggling with it a bit. It does support PD, which is excellent. That would probably be improved. So it is close, but it definitely requires a good hardware revision to bring this up to some of the other RISC-V SBCs that we've looked at, including one next week. So I'm going to say a 3, again, for features and specs. Documentation support. So the documentation is their stock standard PDF, which is like an amalgamation of lots of other PDFs, of course, but it was accurate, so that's pretty good. Clear language, so-so. We could work with that. Mac, Windows, and Linux instructions. There was Linux and Windows instructions, but the Linux instructions were quite limited at times. So, and it's not on GitHub, it's on Google Drive. So I won't actually rate that in here, but the documentation, I'm going to give a 3 as well. It could be a bit better. It could be in HTML format. It could have instructions for using Fastboot under Linux to flash it. It could be written a little bit better and less copy and pasted, and it could be easier to access not being in Google Drive. The documentation's in Google Drive too, not just the images. So 3 out of 5 for that one. Software and images. Well, variations, you got 3. You've got OpenWRT, which I assume works, so it's probably really good for that. It's got the Ubuntu image, which we know works, but has some GPU issues, and it's got their Harmony OS, which I could not figure out and is not in English, and I couldn't figure out how to change it. So the Ubuntu image is with a 6.6 kernel, which is excellent. It just doesn't appear to have all the drivers configured yet. They don't appear to let you build your own image either. Now, you can probably use the Bamboo OS by SpacemiT on this. I haven't tried it out, but that's something we could tinker with. I couldn't see the SDK being available. I couldn't see much information about making use of all the AI features that would be available in this. So it's going to lose points for that. And being available on Google Drive, you have to sign in to download it, which is a pain. So unfortunately for firmware images, they're only going to get a 2. Performance and reliability. General use performs about what I'd expect. GPU didn't work. It hasn't crashed though. It has been moderately easy to use. Wi-Fi seems to work fine and be good strength. It comes with the external antenna. We couldn't do anything 3D, but we will benchmark it at the end. So performance and reliability, I'm probably going to give that a 4 because it's about what we expect, especially with the GPU. And we didn't look at what GPU it's got, but we will see if we can figure that out in a second. Lastly, accessories. So power supports power delivery, which is excellent. It's standard USB ports, could do with another USB-C, dual Ethernet, standard HDMI port, not mini. That's excellent too. You got your 26-pin header here, not a 40-pin, but 26-pin is really good. Supports your cameras, but we do have that limitation there. Doesn't support any of your standard hats, and does support the MIPI DSI display with 3 different storage options, eMMC, SD, or M2. So accessories and compatibility, I'm also going to give it a 4. Does it Arduino? We ask that from time to time, but no. You could program Arduino, installing Arduino on this, but it can't run Arduino code, of course. This is an SBC. So that actually gives us an average of, what's that, 3 plus 3 plus 3. So that's an average of 3. 2 brings that down. So that's going to be 3.5. And on the tier list, if we're to go back to here, that is going to give it B tier, unfortunately. So I'll upload this image and you'll see it on there soon. Some of it can be fixed, like if they put their documentation in GitHub, if they had HTML or Markdown documentation, if they had more images available, they could probably get it close to an A tier. There are some hardware limitations though. I'll say they could get it to A tier with the current hardware limitations just by improving software and support. They can't get it to S tier because of some hardware limitations. Definitely getting close. as you can see, watching YouTube on this isn't going to happen, not anytime soon, and not at 1080 even. But if you want to see a really good board that was really performant, check out this Rock 5 ITX. Now, it's a bigger form factor. It's not a SBC form factor, but that video, if it ever loads the image, was a great product that performed really well. So the last thing I'm going to do now is, of course, download, where's my keyboard? Download Geekbench here, so Geekbench preview, and I'm going to leave this running so we can get some benchmark results on it. Thank you all for coming along. Thank you very kindly to PCB for supporting this video and my entry into the design contest as seen there. Thank you to my patrons who are always fantastic support. No, that was the wrong link. Bloody hell, cancel that. And thank you to all of you viewers. If you could like and subscribe, if you do like this comment, it would be extremely handy because it helps the algorithm, of course, and I'm a bit behind on videos. Don't forget to check out my shop if you want any of this stuff. So it's shop.plati.ma, shipping out of Australia. And I've got heaps of accessories for Arduino stuff, RISC-V, SBCs, everything in between. And I'm adding new products every couple of weeks, as you can see. So appreciate you coming by. I'll see all of you folks next time. And for now, let's leave this benchmarking. Take it easy.